disregarding order, we can write 4 as a sum of one or more integers, each a power of 2, in only 4 ways. 4, 2 plus 2, 2 plus 1, and 1 plus 1, plus 1 plus 1. In at most, how many different ways can 5 be written in such a sum? Alright, so we want powers of 2, so we have 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and I think 2 to the power of 3 is not going to be necessary because that's 8, right? This is 4, this is obviously 2, and this is 1. So we're really only going to deal with these numbers, 1, 2, and 4. So let's see. We're trying to find ways to write 5. So obviously all ones, that would be one way. And let's see, let's stick a 2 in there and see what happens. That would be one way. Let's put another 2 in there. And then I think at this point we can use this 4. And I believe that exhausts the ways. So that's 4 ways in total. What is the ordered pair of positive integers xy for which x plus y is as small as possible and xy lies in the interior of the shaded region? Well, let's see. Let me think about this here. I think this is one of those questions where you probably just make a little diagram for yourself and just see what happens here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And like that. And then we are trying to, what is it? Oh, 9, 3. Okay. Ooh, so I did, this is way too big here. So let me change that. So that's more like it. And then what I would do is sort of just kind of see what this would be. You can create the equation of the line, or you can just kind of make a little table. So we have x, y, x plus y. And then let's see, is it in the interior? Yes or no? Interior. Okay. Let's see what happens here. When I choose 3 for x, this is of course the x-axis and that's the y-axis. When x is 3, which I believe is 1, 2, 3, this, will it be in the interior? And the answer is yes, because it's going to be approximately there. And another way of doing it is by finding the equation of the line. You've got 0, 0, which is the origin right here. And then you've got, of course, 9, 3. And then you find the equation of the line. You guys know how to do that. The equation of the line with those 2 points would be y is equal to 1/3 x. So you can either do it just by plotting, or you can do it with this equation. The equation is obviously going to be more accurate. So if you put 3, you would get 1. So it's actually right on the line. So it's technically not in the interior, right? So this would be a no. And then x plus y is 4, but it's, well, actually, when x is 3, yeah, well, for that case it would be 4, but, you know, it's kind of irrelevant. Okay, let's keep going here. What about when x is 4? So when x is 4, you use our little equation here, and you would get, well, that equation is going to give you something on the line. So I actually want something in the interior. So when x is 4, I'm pretty confident that when y is 1, it's going to be in the interior. So that's good. That's the first one that I got, and this is 5. So this is sort of a potential value for the smallest possible value of x plus y. Now, if the answer is not 5, the answer, well, the sum of x plus y, could it be 4? Well, the only way it could be 4 is if I put 4, 0, let's say, but then 4, 0 is not in the interior. Okay? How about, I'm trying to get 4 here. How about if I put 3 and 1? Okay, 3 and 1 would give a sum, but let's see if it's in the interior. 3, 1, well, we already did 3, 1, actually. And 3, 1 was not on the interior. It was on the line. So we did 3, 1. We did, let's try another one. How about 3, 0. Well, 3, 0 is on this part. So as you can see, once you go through different values, this is the lowest sum you can get for x plus y. And the answer to the question actually is asking you for the ordered pair, and that ordered pair is this guy, 4, 1. So this is the actual answer to the question. The least number of consecutive integers whose sum is 2003 is 2, since 1001 plus 1002 is 2003. What is the largest number of consecutive integers whose sum is 2003? So what they're asking is, if you did x plus 1 plus x plus 2, consecutive integers, x plus 3, and so on, you eventually want to get to 2003. Okay, well, how do I do that? Well, instead of going through this manually, which would take absolutely forever and it's not the right approach, here's something you need to observe. Let's say I took 0 and then I took numbers on either side, -1 and +1. These three are consecutive integers. Now their sum, if you were to add them, their sum is 0. So if I put another number to the right, the sum of the whole thing would just be that number, because these guys all add up to 0. So in this case, the sum is 2. So by the same principle, if you do that again, but this time we want the sum to be 2003, right? So we want the sum to be 2003. So that one will be 2003, kind of sort of like matching the previous example. But then all of these guys have to add up to 0, just like here. So how do we do that? We'll put 0 in the middle, and we keep going 1, 2, 3, all the way up till 2002. And on the other side, -1, -2, all the way till -2002. And that allows me to have a total sum of 2003. Now, they're not asking us the sum or whatever. The sum has already been given. They want you to figure out how many of those integers did you have in your list. Okay, not a problem. From here to here, that's 2002 integers. Then I've got this guy, so that's 1 integer. And then from here to here is 2002 integers. And then I got the last one. So I have 2002 plus 1 plus 2002 plus 1, and I believe that's 4006 total. That is the largest number of consecutive integers that could add up to a sum of 2003. I walked at 5 kilometers per hour down Main Street and left town. A car driving down Main Street at 35 kilometers per hour left town at 10:15 a.m. the same day and passed me at 10:40 a.m. At what time that morning did I leave town? So throughout this question, of course, we're going to use that standard formula that speed is equal to distance over time. And then we are traveling down this street. And let's see what we can discuss. So we have the person, and then we have a car. And the first scenario is 5 kilometers per hour. And at 10:40, I guess, is when this car passes. So the car is passing at 10:40, the person, if I read that correctly. It passed me at 10:40 a.m. a car. Okay. And then the car and the person are traveling on the same road, but obviously their distances, the speeds are different, and they even gave you 35 kilometers per hour for the car. Okay. All right. And he's walking. Okay, I got it. So a car is driving, obviously, and then he left town at 10:15 a.m. So I'll put that here, 10:15. All right. No, the car left at 10:15 a.m. Sorry about that. The car left at 10:15 a.m. We actually have to figure out what is the time that he left. Okay. All right, I got it. So took a little bit of time just to understand that. Okay. So first thing is the time the car elapses. That looks like 25 minutes to me. So we can easily figure out at least something. 25 minutes, I'm going to convert that to hours because everything's in kilometers per hour. So that's 5 over 12 hours. Okay, so now let's use our speed equals distance over time formula, and that's going to help us out. So speed is equal to distance over time. So that means that the distance would be speed times time, and the speed is 35 kilometers per hour, and the time is 5 over 12 hours. So the distance is 35 times 5 divided by 12. Okay, I'm just going to leave it like that actually. And then now finally we turn our attention to me, the person. For his speed equals distance over time formula, his speed is 5. His distance, well, the distance is the same for both the car and the person. So his distance would be 35 times 5 over 12. And then this is 1 over t. So then that would basically be that 5t is equal to 35 times 5 over 12. The 5's cancel, so the time is 35 over 12. And 35 over 12, that is in hours, correct? Yeah, in hours. So we have to convert that to minutes. Well, I mean, it helps if you convert it to minutes. So if we multiply by 60, so that's going to be 35 times 5, so that's 175. So 175 minutes. So 175 minutes from the starting time to the end time. So all you just have to do is take 1040 and subtract from it 175 minutes. And when you do, I believe you get 7:45 a.m. What are values of x? All values that satisfy the log of 5 to the base x is greater than the log of 10 to the base x. In this, I'm going to use a log rule, probably not the most famous log rule, but it's a helpful one, that you have. If you have the log of c to the base a, that's going to be equal to the log of c to the base b over the log of a to the base b, like that. So, and also in this case, I'm just going to let b equal 10, and if that's the case, then you don't have to write in the tens, because base 10 is kind of like implied. And then what else can I do here to make it look similar? I guess instead of a, I will write x, and then instead of c we'll talk about a little bit later, so it'll just be like this, the log of c to the base x. Yeah. And then this of course would become x, like that. Yeah, I think that'll help out. Okay. So then now we take a look at what they have, and we have that the log of 5 to the base x is greater than the log of 10 to the base x. So now we will take our formula, and this will basically be, well, this is the scenario where c is 5, and this is a scenario where c is 10. So using that, it would be the log of 5, c is 5, yeah, log of 5 over the log of x, and this would be the log of 10 over the log of x. Right? Okay, well, the log of x is on both sides, so that cancels. So the only thing you're left with is just the log of 5 is greater than the log of 10. All right. Well, the log of 10, since this was base 10, that's just 1. And the log of 5, are you allowed to use calculators on this exam? And I believe so. So you can easily figure out the log of 5. That's about 0.7. So they're saying that they want 0.7 to be greater than 1. And obviously that is not true. So this is not true when the log of something is greater than or equal to 0. But what's interesting is that if you look at the log graph, if you were just to draw a log graph, so I think it's something like this, right? Where this is the log of x, and that's 1. And this, of course, is 0. So you have two regions. You have the first region where the log of x is greater than 0, and then the other one would be less than 0. So the better way to probably, instead of putting y, just put log of x. So you have the log of x is greater than or equal to 0. So that would be this region. And then you have the log of x is less than 0, and that's this region here. So when the log of x is less than 0, that's when this holds true. That you would actually, this denominator would become negative, correct? And that would flip the symbol. It would become log of 5 greater than log of, less than the log of 10. And that's basically saying that 0.7 is less than 1. That's always true. But it's always true when that holds true, and that happens when x is between 1 and 0. So that is what they're looking for this question. Jack chose 9 different integers from 1 through 19 and found their sum. From the remaining 10 integers, Jill chose 9 and found their sum. If the ratio of Jack's sum to Jill's sum was 7 to 15, which of the 19 integers was chosen by neither Jack nor Jill? Okay, so we have 1, 2, 3, all the way up to 19. And then I don't know if there's a way of doing this systematically, or do we have to just do trial and error? I'm not sure, but let's see. So we choose initially, how many do we choose? 9 for Jack, right? So we're just going to write integer 1, integer 2, all the way up till integer 9. And that's sum for Jack. We'll just write sum for Jack. And then we have how many for Jill? Jill chose 9 as well. Okay, so she's going to go integer 10, integer 11, all the way till integer 18. And then that's going to be her sum, Jill. So I'll just call this S, and I'll just call this whatever, J, I guess. It doesn't really matter what you call them. So then they're saying that S to J, Jack's to Jill's ratio is 7 to 15. Okay, I got it. All right. And then, of course, we have finally this 19th integer left over, and we'll call that A. I don't know what that is. It could be any of those 19 numbers. So this is basically the setup of the question. And now we have to learn how to proceed. I guess our goal in this question is to figure out this number here. What is that one? All right, let's see what we can do. Well, the total sum of those 19 numbers, you can easily figure out. There's that formula, right? It would be 19 times 20 divided by 2, which I believe is 190. So that basically means that 190 is the total sum. And the total sum would be this guy plus this guy plus this guy. So S plus J plus A. Those are basically all 19 of the numbers. Then we have that piece of information, which would give me that 15S is 7J. Okay, let's substitute that in, and that let's make it into 1 first. So 7 over 15J, and then we'll plug it in. So then it'll be 190 is equal to 7 over 15J plus J plus a. That's still, we have two variables, but at least it's better than 3. And if we add this, that'll be 22j over 15 plus a. Okay, we're making progress. Okay, now I think is where the trial and error comes in, because unfortunately we have two variables, we don't have one. If it was one, it would be much easier. So okay, let's see what we can do here. Let's see, what can I do? Now these are all integers, so if I look at that term there, that has to be an integer, right? Because if you add that to a is an integer, we've already defined that. It's going to equal 190, and 190 is an integer. So that means that j must be a multiple of 15 in order for that to be an integer. So multiples of 15 are 15, 30, 45, 60, and so on, right? 75, blah, blah, blah. And all the way up till, what's the highest it could be? 180. Yeah, because it can't be higher than 190 because a is positive. Okay, that helps, because otherwise I would have no clue what to plug in for j. So which way should I go? Should I start with the small one and go up, or should I start with the big one and go down? Let's start with the big one and go down. So let's start with 180. Okay, if j equals 180, I'm plugging j into this formula here to solve for a. I will get a equals negative 74. I'll let you do the math. It's fairly straightforward. Okay, that's no good because a has to be a positive integer, and it's got to be one of those integers. It's got to be 1 through 19. Okay, let's keep going. If j is 165, which is the next one down, a would be minus 52. If j is, what's the next one? 150, right? A is minus 30. Okay, we're going in the right direction for a. J is 135, a is negative 8. And I have a feeling the next one will do it. When j is 120, a is 14. And let's just do one more. When j is 105, a would be 36. And obviously, that is outside that range. So I am confident that a is 14, and that is the answer to the question.